Okay, so in the first lecture we said that a magnet creates around it a magnetic field, right? So we saw in this slide, for example, this is a magnet, this is the North Pole, South Pole. So the direction of the magnetic field, by conventional, it goes from north to south. Okay, this in a magnet. What we want to discuss now is the other way to generate a magnetic field, which is by having charge in motion. Okay, so in this slide now, what we have is current, and around current is charge in motion. No? So around this current, we are going to create a magnetic field. Okay, so around this wire, we have magnetic fields, and the way they are indicated in circles. Okay, all around this wire, small circles, big circles, no, because all around there is magnetic field. So the circle indicates the direction of the magnetic field around a wire. What we want to decide now is in which direction we should, along this circle, we should follow. And for that, we use a rule, it's like a game, which is called the right hand rule. Be very careful, especially people who write with the left hand. You can only use the right hand, okay? The name of the rule is right hand rule. If you use your left hand in this little game, you're going to get the wrong answer. So watch your hand, only use your right hand, okay? So how does this rule work? You pick your thumb. Your thumb has to be in the direction of the current. So you see here in this wire, the current is going up, so the thumb is going up. And with your hand, with your 4 fingers, you grab this wire. And the 4 fingers, the way they are encircling this wire, will tell us the direction of the magnetic field. So you see these 4 fingers, they are closing the wire in this direction. So we see that behind the wire, the magnetic field is going to the left. Here on the left side of the wire, the magnetic field is coming towards my eyes, outside the screen. Here in front of the wire, you see the fingers. So in front of the wire, the magnetic field is going to the right. And here on the right side, the magnetic field is going into the screen. Okay, so we have this whole circle indicating the direction of magnetic field. So these 4 fingers, the way they're encircling the wire, is telling us the direction of this field. Let me show to you some other drawings of that. Let's see if this helps. In this case here, what we have is a wire, and the direction of the current is now to the left. Okay, so the current is to the left, my thumb is to the left. The thumb is to the left, this is my right hand. Now my thumb is to the left, and with my hand, with my 4 fingers, I'm going to encircle the wire. And you see that I have now these circles, so all these circles are indicating the magnetic field. And what is the direction? In this direction here, as you see in the drawing. Now, so in front of this wire, the magnetic field is going up. Behind the wire, the magnetic field is going down. So I have this whole circle here. Let me show to you another drawing. This is the one that we already saw. So the current is going up. So my thumb is pointing up. And what is the direction of the magnetic field? This circle, so that in front of the wire, the magnetic field is going to the right. Behind the wire, the magnetic field is going to the left. Now let's see another case where the current is pointing down. So my thumb is pointing down, and we are here encircling this wire. You see now that the magnetic field is going to be in this direction here, meaning in front of the wire, now we are going to the left, and behind the wire, we are going to the right. Okay, so get a pen and start playing with it. Now use your pen to indicate the direction of the current, and play with your right hand to try to get these circles in the correct direction. Let me show to you one more illustration, which is animated, so that may help us see what is going on. So this is the wire, the current is pointing up, and we are encircling no? With our four fingers, so the current is pointing up. These circles are all indicating the magnetic field, and you see the direction. Now this yellow line is indicating the direction. Look, in front, behind, in front, behind, in front to the right, behind to the left, in front to the right, behind to the left. So we have these circles. All right. Let's see another video. No? Now the current is going down. The current is going down. We use our hand again, thumb pointing down, and we are going to get the direction of the magnetic field. Now, in front, it's, well, now it was too quick. Let me show it again. So, in this case, in front to the left, behind to the right. Now we are going to see both together. So in this case, the current is going up. In this case, the current is going down. So you see this one to the left in front, this one to the right in front, and this one to the left in front. Yeah. So I hope this made the direction clear. You have to play a little bit, and we can talk more about this. There are other scenarios where you can have a more complicated direction of the current. Like in this case, we have the current going through a circle itself. And well, you would use the right hand rule the same way, pointing your thumb pointing the direction of the current, and your four fingers encircling it. So here you get the directions of the magnetic field, but I don't want to go too much into this. All of our problems will be involving straight wires like that, so you don't need to worry too much about this, just if you have curiosity. Okay, now let me continue a little bit more with this story. We are going to talk about what is going to be the consequence of this magnetic field created around the wire. We already saw one consequence of the magnetic field when we are talking about Earth. We said that Earth has around it a magnetic field. What is the direction of the magnetic field on Earth? This direction. This is the north magnetic pole, and we have this direction of the magnetic field going towards the south magnetic pole. So this is the direction of the magnetic field on Earth. What is the consequence of this magnetic field? If I bring a magnet close, this magnet will feel a force. In our case here, the example that we brought is the compass, and the needle is a magnet. So because of the magnetic field, the needle gets aligned with the magnetic field, so the north pole of the needle points towards the south pole, the south magnetic pole of Earth. Okay, now let's go to our wire. So the wire here, we have current pointing up. Around this wire, we created these circles, which are magnetic fields. What is the direction of the magnetic field? This circle moving like this, in front of the wire is going to the right, and behind the wire is going to the left. Okay? If I bring many magnets now close to this wire, they are going to feel the magnetic field created by this wire. Because this magnetic field will be larger than the magnetic field of Earth, and so now our magnets will get aligned with this magnetic field created by the wire. And this is what you're seeing here. Now, so these needles, they are now aligned with the magnetic field of the wire. Okay, and if you want to know, the red point here is the north pole of the needle, and this white side is the south pole of the needle. Now, so they are aligned with the magnetic field created around the wire. So this is the end of this discussion. So the discussion here was the direction of the magnetic field created around a wire that has current. Okay, so this is the end.